Acceleration is done using parallel processing. Nvidia had to invent a computer for that. We invented the GPU. Some people will say AI, it's like a hype. I think it's underhyped because it enables automation, and that's where you get exponential productivity improvements and cost savings. There's hundreds of AI for AEC startups. It's like the golden age of entrepreneurialism in AEC.
Have you ever wondered what connects your gaming computer to the construction and engineering sector? Hi and welcome to the Innovation Labs. I'm Grace Newey and I'm joined here today by my colleague, Jack Lee. We're from Atkins Realis. And today we'll be speaking with Sean Young from Nvidia on everything to do with AI, digital twins and the future of technology in the engineering and construction sector. Hi Sean and welcome. I am wondering if you can tell us a little bit about yourself and the work you do with Nvidia.
Yeah, sure. Well, first of all, thank you so much for having me. It's a great honor. At Nvidia, I take care of AEC and geospatial. And I lead a team of enterprise marketing people focused on different industries. And with AEC now, it's so important because of what's happening with the growth of these large data centers that need to be built in a way that enables a very efficient conversion of energy to compute. So I'm looking forward to discussing that with you.
Awesome. Thank you. I mean, one of the things I'm really curious about, I think, you know, most people in corporate functions these days have heard the term GPU. But I was just wondering whether you could explain a little bit to us about the sort of history of what a GPU is and where we are today.
Sure thing. So everybody knows what a CPU is. And the CPU, and you have one on every one of your computers and mobile devices, and the CPU is very good at basic computing tasks. It's like housekeeping of the computer. But where it falls short is accelerating things, because acceleration is done using parallel processing. In other words, breaking a problem down into smaller parts and running each part on what's called a core. The CPU has a limited number of cores, like your desktop or your laptop might have 10 or 12 cores. So that wasn't enough for these very complex problems that had to be computed very quickly. In the case of Nvidia, that was graphics for gaming, because to have an interactive gaming experience, you need 30 frames a second. At least. And there's a lot of information there in those pixels. But what you can do is you can take all those pixels and send them to a different core to be processed and brought back together in real time. Nvidia had to invent a computer for that. We invented the GPU. And that's exactly what it does, because it has thousands of cores. Over the years, we've increased the number of cores. And it turns out that this methodology of parallel computing works not just for graphics, but for all kinds of very computationally intensive mathematical processes, algorithmic equations, weather prediction, computational fluid dynamics, and of course, AI, where tons of data has to be trained. It can be broken down into small parts and computed on these cores.
Interesting. So just for some context, how big are we talking when it comes to data centers? You know, if we've gone from this journey of having a GPU that was created to accelerate that speed and performance, just what kind of size are we talking about with some of these data centers?
Yeah, as big as you can get. Now we say the unit of compute is data center. And the reason is because it used to be that the unit of compute would be the GPU. And then you had a finite number of cores in the GPU. That wasn't enough. So then we figured out how to connect multiple GPUs together in one computer, a server or a desktop, over the hardware interconnect. But that wasn't enough. And then we figured out how to connect multiple servers together. And this is really complicated because now you're going outside of the PCIe bus and you're getting into the networking. So we had to invent that networking to be able to enable GPUs and different computers to talk to each other like they're in one GPU all the way up the rack. But that wasn't enough. We have to scale out in what's called east-west across the data center. And, you know, maybe one day we're going to have to connect multiple data centers together. And we're working, this is what keeps Nvidia up at night. We're trying to innovate in every element that impacts performance and conversion of energy to compute, which is a real critical factor that affects Atkins Realist and all of your customers.
I think it helps to clarify, because it can be quite complex. There's so many different partners involved in the ecosystem. You've got hyperscalers who kind of wear two hats sometimes. They'll have their own, they'll rent out space. You've got all of the partners who are providing the networking infrastructure equipment within that. But then there's the software piece, right? And so the worlds of, I guess, kind of cloud compute and physical compute, and now kind of AI, they're all merging together a little bit, right? And everyone's doing a little bit of everything. So it's good to just try and understand kind of where NVIDIA is playing today and maybe where it wants to go.
Yeah. So what you're describing is actually a real problem. And the problem is if you try to assemble the jigsaw puzzle of a data center with a whole bunch of different component parts that aren't designed to work together, you're taking a chance, or you're almost guaranteeing there's going to be challenges, which is why NVIDIA creates the full stack. We create the GPU, the CPU. We even have a chip that has the GPU and the CPU on the same die for optimal efficiency, performance, and energy consumption. That's called Grace Blackwell. And we create a whole bunch of networking technologies that are built around our architecture so we can optimize, again, performance, scaling, and energy consumption. Wrapped around all this is a whole bunch of software. We have over 1,000 different SDKs and libraries for computational acceleration, HPC, domain-specific solvers and other such things, and a whole bunch of AI technologies and management administration technologies, again, to optimize the performance of all of these components as a system. That and we're working very hard to make sure all these things work together, and we can control for all of that. For example, we have a toolkit based on Omniverse, or Omniverse Digital Twin development platform, and the toolkit's called the Data Center Digital Twin. And what we're doing is simulating these AI factories based on the MEP, the specific MEP configuration, based on the actual configuration of the racks, the servers, etc., and based on simulating different types of AI models or HPC simulations. And then we could see the output and the conversion of the fixed supply of power to the compute output. Then we can make tweaks in this digital twin environment before any concrete is poured or MEP components are ordered, to make sure we get the right recipe for optimal basically profitability. We say, these data centers, that are built for AI, we call them AI factories. They could be highly profitable, and that's the objective. But you have to maximize your efficiency of energy to compute conversion, which, as it turns out, is good for the environment as well in terms of sustainability. So we're completely dedicated to that mission, and now working with all our partners and developing software and working with other software partners so they can plug into this ecosystem.
That's a tricky one, because you brought up the sustainability piece, right? I know that fundamentally, the world is looking at using AI. It's more and more pervasive in people's lives. With that, particularly, I think for some of our newer joiners, our graduate students who are joining us, they're asking the question, has anyone actually thought about all of this AI usage? What impact does that have on the environment? And I'm sure that you, as NVIDIA, gets that question quite a bit, right?
The education piece on this, I think, is such a big thing, and certainly something we're experiencing in our organisation in terms of making people aware about the fact that if you put please into any kind of chat agent, that uses energy in a data center to actually process that. And I think it's interesting to see this journey in terms of how we actually educate ourselves and understand how we should leverage tools like AI. I just wonder, Sean, from your perspective, is this something that you guys regularly talk about or consider when it comes to, you know, what you're servicing in terms of the end user and how they might interact with that, and what provisions you have to make as an organisation for that journey we're going on at the moment where we're not perfect operators of AI?
Yeah, I think it's a really important question. And I think what it, at the end of the day, comes down to is every organization's mastery of the subject matter. So I think now we're, unlike 40 years ago when AutoCAD first appeared at our doorsteps and nobody had a computer, now you all have like software engineers, software developers working for you, developing internal tools. You know how to do coding. You already have like a high degree of proficiency in all of this kind of computer software development. AI is the next evolution of that. So I think having this internal ability, a center of excellence to refine AI as it comes to you from software, from the main software companies and all these startups, and develop your own AI solutions is critical. Then you can optimize for things like you're talking about. You could build in guardrails. You can have, GUI for prompts or some watcher that eliminates please when it's typed in. All of that is possible if you have that in-house expertise.
I mean, is there something we should be doing as industries to accelerate this process between technology and the AEC industry in terms of realizing that optimization? Like, it's such an important thing to us all as businesses. Like,
I mean, we struggle with silos. Not every business struggles with silos internally. But I think in particular, our industry really struggles with so many different software providers to do the work that we do. Oftentimes it's the same task, just for a different industry. And then, they have other kind of more specialized software. And then you have all of these different project partners on any given project, whether it's a building or data center. You've got 15 different organizations sat around the table, each handling a bit of that building. And they all have to come together, but they may all have used different software. Hopefully it talks to each other, but it doesn't always. And so it's this, we can mention interconnectivity, right? For our industry, we need to have all of that talk to each other, and then we can do some really interesting stuff. And there's things that have happened since then. There's APIs. There's more open formats for things like BIM data, right? But then there's other stuff that I know that Nvidia, we talked, Omniverse, you've mentioned as well, right? There's opportunities to bring a lot of that information together, right?
Yeah, Nvidia is completely committed to open standards because we want to work with everybody. Mm-hmm. And you can't do that if you bring to the table yet another proprietary file format or proprietary method of doing things. So we look for open standards and we encourage the adoption of those. One open standard that we are very excited about is OpenUSD, and that's being used to translate BIM data and other types of data into some like normalized, homogeneous, human readable data that can also be compiled. And it's really exciting what you can do with this. And the Alliance for OpenUSD is the consortium that oversees OpenUSD. Many of the big software companies that you're familiar with are members. And there's a AEC working group working to rationalize IFC with OpenUSD. And the idea would be to be able to represent like IFC schemas as USD as an example. So they're complementary. In addition, like to go back to your question, many of the AI challenges in terms of like customization, fine tuning, guardrails are common to all industries. So NVIDIA develops toolkits, many of which are open source again, that you can use. And then we have specialized toolkits called Nemo that help you do customization, fine tuning, guardrail, inference deployment, all of that. So we're thinking about these things and methods to make the process easier for our customers.
So when you start to pull all of this together into one piece, so you've got the sort of AI, machine learning components of it, optimization of processing, some of the things you just mentioned about BIM information and BIM data and putting that all together. And then you start to get more intelligent outputs like digital twin outputs. I was wondering whether you could tell us a little bit more about some of the work that Nvidia's done on digital twins and what you see the future of the industry with digital twins is looking like.
Yeah, so maybe the layer before digital twins, when the transition maybe from digital twins, from AI to digital twins is physical AI. Because we see this progression of AI from, it started with image-based AI, being able to do, recognize a cat or a dog. Then along came generative AI, where we can actually have AI create things for us and chat. This is like the chat GPT moment. Now we're doing diffusion, where we're creating imagery, and that's really important for AEC, text to images or sketches or wireframes to images, etc. With similar technologies, we can even start to do the engineering work using multimodal technologies. And then we get into agentic AI with different models that are optimized for different things working together. And to me, this is incredibly exciting. Some people will say it's like a hype or a buzz, but if anything, I think it's underhyped because it takes the human out of the loop and enables automation. And that's where you get these exponential productivity improvements and cost savings. What comes next, and we can go back to agentic, there's a lot to unpack in agentic. Physical AI, though, is really important for AEC because everything we do in the built world is subject to the laws of physics. So to have all this AI that doesn't understand physics, you will result in mistakes and problems. So we believe, and we're training AIs based on physics, and I can give you a few examples of this. The way we do that is with a digital twin, because in order for the AI to understand the world around us, you need to give it training data. So that means you can either go out in the world and take lots of videos and describe things or whatever, and simulate these scenarios, which you don't want to happen in the real world, like a kid jumping in front of a car to train an autonomous vehicle, car for self-driving. You want to do things like that in the digital twin, where you can create unlimited different scenarios without putting anybody in harm's way, and create a wide variety of domain randomization. So it's in night, it's in day, it's snow, it's dry, sunny, rainy, whatever. And all of this becomes what's called synthetic data for an AI. And that's the fundamental reason why we have a digital twin that's physics-based, that's being used to train physics AI. But there's a number of other use cases, like simulating different scenarios, similar to how we're accustomed to doing visualization of designs before they're built. Digital twins based on Omniverse take that to the next level in terms of physics simulation of the thing and all the different variations of the asset before it's built. So we find those errors, not just by seeing them, but by observing the physics behavior of them.
I think that's going to be really key because, as an engineer, I myself, not an engineer, but as an engineering company, certainly, I think we understand the importance of getting that right. And one of the challenges around thinking about AI in this space is how do we know that it's right? We know that today, particularly for generative, there's hallucinations and then there's errors. And, in our space, we can't really have errors. We can't sign off on a bridge or a building that is only kind of right. It needs to be right? And then the problem is well, if you have AI, for many people, it's a bit of a black box. You don't really know how it works, how it arrived at the answer. And some of it's better now at kind of walking you through the steps, but it's still kind of, you provide an input, it gives you an output. So how do you review the outputs from an AI? How do you review it and be confident and assured that it may have designed a bridge correctly, right? And so, one of the things that struck me was when you were talking about actually doing the tests, simulating a million lifetimes of an asset, far more than what we would normally be able to do as just that extra level of assurity that yes, actually The math does check out. We've done all of the tests. I don't think we're going to be in a place where we're going to be removing the human from that activity or equation anytime soon. But actually what we have here is the ability to get more confident in the capability of AI, and at the same time also kind of complement the human being's ability to do so. Say, look, you've done your checks as a human being, and we've also had AI check it 1 million times, on top of that. So you can be really confident to kind of sign off on that.
Yeah, exactly. Yeah, there's no need to take the human out of the equation at the moment. But the use of the term 1 million is very relevant here, because normally to get 1 million permutations of something would take at least 1 million hours. And nobody has that kind of time. With AI, those 1 million permutations can happen instantly. And as an example, like with physics informed neural networks, PIN, this is a method of doing physics simulation, but instead of simulating, which is computationally intensive, takes those 1 million hours, takes time. You have to do it in an HPC, high performance compute cluster, lots of servers, every time you run the simulation. Instead, you could do predictive physics with a physics-informed neural network.
Yeah, it's so interesting, because I think there's this real theme at the moment of what's the future of the workforce. What does this actually look like in practice? Because we recognise that we can get so much efficiency, so much time saving, so much processing power from tools like AI that we just haven't been able to have before. But what do we need to do to make sure we've got the ideal workforce? What does that actually look like in reality in terms of that human augmentation with AI to get us to where we want to be? And I guess I'm curious, Sean, from your perspective, do you have any views on what you see the ideal workforce looking like over the next 10 years in order to make this really go to where it has the potential to?
Yeah, I think about this very often, because I have 2 kids in uni for engineering, and civil environmental and mechanical, leaning towards civil. And, we talk about this all the time. They're putting so much work into their studies. Will they have a job, or is it going to be replaced by AI? And, I honestly don't believe that their job is at risk, as long as they know AI. I think people that don't know AI or refuse to learn AI will eventually get phased out and replaced by those who do. And the analogy is just, like BIM. Well, some people were like, CAD is good enough, I'm not going to, learn BIM.
Those people still exist, by the way.
So, I mean, the CAD has its place. Not everything requires BIM, but, where BIM is required, the people that didn't want to adopt it found themselves looking for different kinds of jobs. And I think it's going to be the same thing with AI, but even more so because AI permeates into everything. It's not just for one specific thing. And like BIM is for buildings and such. So AI permeates into everything, and every application, every work process, everything we do on the administrative side, in HR, in estimating and responding to RFPs, in design, conceptual design, engineering, creating construction documentation, correlating the construction design back with building code, make sure everything is fine, policies for nuclear. Everything is going to be optimized. Construction, operations, everything's going to have AI in it.
Yeah. And I mean, it's been around for way longer than generative AI. Generative AI is in the public eye, right? So we've been getting AI. Netflix has been recommending me stuff using AI for years, right? We have excellent grad programs, by the way, for if they want many different offices around the world.
Oh, good to know. Okay, we'll have to chat with them about that.
Yeah, it's really interesting.
I'll try to make a couple of great AI engineers for you. I'm working on it.
I mean, if they're civil, we need more engineers. I think that maybe that's part of the message as well, right? Is not, we're not saying these maybe we'll call them traditional disciplines, they're not going away. We need to build more data centers, power plants, bridges, roads. We don't need to build less. We need to build more.
Build more and build smarter.
Yeah, right.
Yeah, it's trying to find that perfect blend, isn't it, of those. because we don't want to remove people's expertise from our industry. We don't want to say we don't want civil engineers anymore, because we need them to help do the validation and help train and help AI give us what it's capable of giving us. But it's just shifting people's mindsets into that technology curiosity, I guess.
We want civil engineers who think differently.
Yeah.
Not no civil engineers.
And understand the technology. Just like, 10 years ago, you wanted civil engineers that understood Civil 3D, et cetera. Today, you want coming out of school. Today, you want a civil engineer that understands Python. My kid, one of my kids has Python in his first year. And the other one who doesn't, I've been chatting with the administration about the curriculum, and they're like, yeah, we're modernizing our curriculum, and it's completely AI factors in, and the kids are going to come out knowing AI for engineering, for domain specific, application.
So if Sean Young from Nvidia has one thing to say to the future generation of engineers coming into the AEC sector, what would your message be? For
students, AI is not cheating, just don't use it to cheat. Find a way to use it productively. And tell your professors about it, because that young people are the people that are going to change our world, and now they have the toolkits, they have the Lego building blocks to go do whatever they want. The sky's the limit with AI. We're just getting started. They're going to be the ones that architect our future. It's really important that they come out of school knowing about what is at their fingertips, the power in AI.
They're in a tricky spot, aren't they? If you think about it, they're in an environment where they're being told, don't use AI to write your assignments and reports, and then they're being told you're the young generation, you need to be innovative and kind of really tech savvy, and then they get into the workforce and they're like, use AI. Everybody should be using AI, and then they frequently, unfortunately, in our industry, they're then met with managers who may have been doing things the same way for 20, 30 years. No, you don't do it like that, do it this way. Why? Well, this is the way that's always been done. Right? So they're in this very confusing kind of, and they've been raised in a very confusing kind of, the technology has developed so fast, one generation to the next is seeing leaps and bounds in the way that they will interact with technology. And so then they're getting into the workforce and they're being told, do something totally different than what your boss is telling you to do, right?
Mm-hmm. Yeah, well, I think that's where upskilling and reskilling comes in for the whole organization.
Yeah.
And I'm seeing that happening now in the AEC industry, where there's company-wide resources available for employees to understand AI and to apply it on a daily basis.
And maybe that's something as two industries we should be collaborating more on and could collaborate more on. Sean's in an industry that has this quite poetic cycle of system integrations from different sectors and parts, and maybe that's just another one that needs to be added into the mix with companies in the AEC sector on how we can future-proof our industry.
AI is going to create wonderful things. It's going to enable wonderful things. To me, it's like the building blocks, and we're starting to see the things that couldn't be done without AI come into being, namely robotics. Robotics needs AI, and it needs physical AI because robots are interacting in the physical world. And the rate of innovation and product releases in robotics, I think, is going to surprise and amaze us. And I'm really excited about that area. In the realm of power, we have fission, but fusion is on the horizon. I think AI is going to help accelerate that. We're seeing AI being used for fusion, and AI is being used to simulate and imagine quantum, and quantum is going to help accelerate these things as well.
Yeah, it's a different way, and also I think one of the things that we sometimes don't fully appreciate is that if you ask an AI to design something, it will do it in a way that a human being doesn't think, but still meets the specifications. Mm-hmm. I've seen this image of, it's kind of like a brace, a corner kind of connector, and humans will design it as humans have always designed it, which is kind of a couple pieces of metal in an L shape, right? But if you ask that an AI the same problem for it to satisfy the same physical properties, to be honest, when I saw the output, it doesn't look like any L shape. It's this like kind of almost wireframe type of shape, but it satisfies. So it kind of, to your point about fusion and optimizing the design, it's a problem that we haven't cracked as a society. But maybe it's because we're trying to approach it from a human's perspective of how do you design a fusion reactor? Kind of making incremental changes. You give the problem to an AI, like, well, actually, I'll kind of do it from a completely different angle that satisfies your requirements, right?
Yeah. Well, humans design things very linearly. We go from conceptual to schematic to DD. There's a linear process, and we lay down the foundation, and we refine and iterate and refine and iterate. And other people may give different opinions, but typically everybody's been trained the same way, is using the same software, and culturally are very similar. So the designs look very similar and standardized. But if you use AI, especially like agentic AI, where you have different AIs that understand completely different things. You have your physics AI, you have your aesthetics AI, you have your environmental AI, you have your revenue generation AI. You have all these. I'm thinking about a building as an example. You have all these different AIs with different objectives. As long as they're given a common set of objectives, which in our world will come from the RFP, so then you can have them working together to achieve a specific outcome, and the design that they create is optimized for that outcome. Does it need to be iterated? I mean, it could be iterated, but physics is built in there as one of the agents. So in effect, you shouldn't get a design that doesn't comply with earthquakes and flooding and wind noise and such, because it's been designed to be optimized for those things, along with the usage of square footage for the building type, like a hospital, along with the corridor requirements for hospitals and the building code and all of those things all together. To me, that's incredibly exciting. And nobody designs that way, because humans don't have that kind of capability. We're not wired that way. And all of this is done based on training, the AI being trained on data that's been labeled as best of its class by humans humans are able to get in and do those weightings on what data should be identified as the best. And then you have an AI that can do its best work.
What's your message to those people who aren't excited? What's your message to the skeptics?
Honestly, I'm too busy with the people who are focused on this to care about the skeptics. Just stand by and watch things happen.
Yeah.
'Cause it's happening.
Yeah.
It's happening, and it's happening. There might be more skepticism in AEC than other industries. Working at Nvidia, I have the privilege of seeing what's going on in all the industries. And I could tell you that AEC is definitely a laggard. That's probably not a surprise, because
not at all.
The construction industry is a laggard in technology and technology investment in general. And I think there's a lot of dependency on the software vendors to define the way we work. Really interestingly now, there's hundreds of AI for AEC startups. And there's VCs now specifically for that purpose. I've never seen anything like this. It's like the golden age of entrepreneurialism in AEC. So I think like all of this is going to come together to completely transform the way we work.
I actually came from a startup. So, I was on the other side, so to speak, trying to sell and convince this, large companies in this space to think about things disruptively. And I think we would, as some of the larger players, I think we would be deluding ourselves to think that those startups are not working tirelessly to try and do the way that we do things, do them in a better way directly to our clients. it might take a little bit longer than, an app that gets released to the consumer market that is very quickly can be taken up because of the kind of the nuances of this industry, because it's quite siloed, lots of different software vendors and also lots of different players. We kind of touched on that. Just because it's going to take longer doesn't mean that there's active VC funding behind it, and these startups are actively talking about companies, about us, about Nvidia, about how to work with us, how to work better than us, right? I think we'd be deluding ourselves if we thought that wasn't happening.
Yeah, it's happening. And what's really interesting is that I love is these startups I'm sensing in a large way are focused on a very specific thing, a very small, precise part of the workflow that they can optimize that fits in. Maybe it layers on top of a BIM application like Revit or something like that. For example, there's one called Archie that does building code. So correlates your BIM back to the building code to check for any errors, et cetera. Or allows you to, type to LLM, chat with the building code. I think there's great opportunity for companies like Atkins Realist to start figuring out which pieces of the puzzle fit where in terms of your workflows, which ones are the best of breed. That's why we're creating this directory, because we want to identify the best of breed, because there's some other firms that are using AI as like a marketing tool, but not really building in AI functionality. So we're going to separate those and focus on the ones that are really delivering AI.
So Sean, if we look ahead to maybe 5 years from now, do you have a vision for what AEC could look like?
Yeah, it's a really interesting question. And I think, 5 years ago, if you had asked me that question, my answer would have been completely different, because, 5 years ago, we didn't know about ChatGPT, did we?
I don't think so.
I think that was 3 years ago. So, the rate of change is extraordinary. ChatGPT changed all of our lives, and it made us aware of these technologies. That was just 3 years. So 5 years from now, what's going to be the next thing? What's the next ChatGPT? Because there's going to be one. Is it robotics? Is it agentic AI? Is it more of this physical AI integrated into all of our workflows? Is it outcome-based design? I suspect it's a lot of the stuff that we talked about today, but just all coming together to optimize the way we work. And that might be a progression. We're starting to see it now, because from the big software companies with 30-year-old software applications with millions of lines of code, it's a lot of work to figure out, how do you add AI? Where do you put it in, and how do you change the UI in the workflow? For these startups, they have to get it all together and go to market and get their idea, realized with limited dollars. But I think all of these things are going to come together. But most importantly, is companies like Atkins Realist having the knowledge of what to do about all this stuff and how to make it work for you, and how to use your data to fine tune and optimize all of that, to tap in to the secret sauce that makes your company so unique, and, the areas where you really outshine your competition. Could you bring all of that core competency and decades of experience into an AI?
Sean, thank you so much for joining us today. That's been a really, really interesting discussion. I'd like to end this episode of Innovation Labs with a few quick fire questions, if that's okay.
Sure.
The first one, so what's your favourite invention from the last 50 years?
Well, it has to be computer. It's changed my life. Yeah. I'm sure it has for you as well.
Yeah, awesome. And what book are you reading at the moment?
I'm reading the new book by Dan Brown. I just started today.
Awesome. And finally, Sean, what piece of technology do you think is either underrated or overhyped?
In AC, it's AI, and specifically agentic AI, as underrated, underutilized. So I think there's a lot of room for that to completely change the way we work. I'm so excited to see what you guys do with it. And hopefully this video will change the perspective of all the audience as well.
Yeah, amazing. Sean, thank you so much for joining us today. That's been a really great conversation. This has been another episode of the Innovation Labs. Thank you for joining us, and please comment down below and let us know what you think about some of the topics we've discussed today, particularly AI, digital twins, and the future of technology. See you next time.
The simple fact is the greenest asset is the asset that's already built. The bridge almost becomes a living organism with a health monitoring device built into it, and we update that data point from maybe a year or 2 years previous. And actually is finding people who are bold enough to take a step with innovative and now proven technology to really drive the outcomes that the asset owner community needs. Because sooner or later, frankly, a bridge is going to fall over.